Hello friends, today we're going to look at this coffee maker. This is one we've used in our house for the last few years. It finally went kaput, so I thought I'd take it apart for salvage. I don't know what's wrong with it, probably isn't worth fixing, and we've bought some new ones by now, since a coffee maker is one of those things you kind of can't live without if you like coffee. So I thought we'd see what all is inside here. Now there's some things we can expect. We've got some sort of control buttons and microcontroller here. We've got a heating element. This is a type that has a pot here, normally where my little friend is, and an espresso machine. So it has at least one heating element, maybe two. In particular, it has control elements to run some sort of high power under the control of the microcontroller, and that's kind of what I think we'll be getting out of this from a salvage point of view, is some of the high power electronic controls. Now, from just a curiosity point of view, this is one of these things that kind of magically works and you don't really know all the details. I don't think they have pumps in them, but water somehow gets from the bottom to the top. So I'm assuming that's based on some sort of heat transfer method, but we'll find out. Maybe they do have pumps in them. So stay tuned and let's see what happens. The way this one works is you put water here to fill up the tank along the side, coffee and filter in here. This is a special top that's got kind of a pressure lid on it that's for the espresso side. There's some mechanical parts. I already took the little espresso thing out. Now I'm taking these screws out, which are a special type, but got my big assortment of special type head screws from Harbor Freight, highly recommended. Take the last of 4 of these out. My experience has been there's probably some that I haven't found yet, but these are the obvious ones. And also something like this may have a lot of clips and things that we have to figure out how to undo or possibly destroy in the worst case. There's more of these screws on the bottom, so we'll go around and get those. So this has these little rubber feet on the bottom, which I've found in the past often hide screws, but in this case they don't. They're just plain rubber feet. I've turned this over upside down after getting all the screws out. We're going to pull this out and see what's inside. See if I can do that with one hand while I film. Aha! We have some major elements. I'll go ahead and take things apart further and show you what's inside next. Well, this is interesting. We've got this kind of strange junction thing here to connect the guts of it with the bottom and the power cord. So that's about all there is to the bottom. It's just pure plastic along with routing of the main power cord. So here's a little insight into how this was assembled. Notice this large hole on the back. So they seem to have planned for you to maybe this whole bottom piece is one assembly. I took these ends off of the little junction block, which is right here. It was screwed on very tightly with some screws, which is a good safety feature. So let's take an initial look at what we've got. This is the water tank. This is the coffee pot heater, which it looks like is also the water heater. So we go through maybe here from the tank and up through another spout, which ultimately drips on top of the coffee grounds and works its way back around through. This is a separate heater element for the espresso, and pretty much knew there had to be 2 heater elements here. Thing I'm a little surprised at in a way, but also makes sense now that I see it, is that this heater element is not only keeping the coffee pot warm, but more importantly it's actually making the coffee. So that's kind of the design concept here. You always want to use the minimum number of parts to get something to work. And this type of, they're called automatic drip coffee makers, came into being in, I think, the 70s or something. Maybe the first one I'd heard of was Mr. Coffee. But before then you had what was called a percolator, which was an entirely different design. Those are still around for, you know, like large institutional use, but they're kind of not used in homes much anymore because the coffee isn't as good and they're a lot more trouble to deal with. So we're going to take these holding clips up off the water pipes. We'll see if this is a usable shot or not. Probably not. There we go. We've got a variety of screws here, which I'll undo separately. In the process of undoing some screws, I realized this is something to talk about. This appears to be a temperature sensor, or maybe a pair of them. You can imagine if this is getting too hot, either in general because it's just plain overheated or shorted or something, that's one thing. Another thing is, if you've taken the coffee pot off, you don't want to have a fire hazard. So without the coffee pot to kind of, let's say you've already made your coffee, you get the coffee pot to create, to in effect dissipate some heat for you. And if the coffee pot is off, this might get overheated, and then we want to have a safety mechanism here. So these are probably heat-based cutoff switches, maybe at 2 different temperatures. Here I've removed the heating element from the bottom of the little pan that holds the coffee pot. You can see there's a little bit of heat grease left over here. This is plainly a piece of steel or something, not of any interest at this point. Got our heater element and switches and tubes that we've seen earlier, as well as a connection to this junction block. This is a strange little piece at the bottom of where the espresso cup pot would go. This is a water pipe of some kind that's ended here but has an opening there, and somehow that would have gone into this area here to do something, keep your coffee warm, I'm not sure. So this is the control panel, now upside down with the espresso output here. I'm going to take out some screws here and should get access to the control module, which is very likely in this area. Thought I'd try to get this top part off. After undoing some screws, it's not really budging. We've kind of reached the point where I may need to do some destruction, which is okay because I didn't plan to fix this or reuse it in any way except for just parts. So I've got 2 of my favorite tools of persuasion here. Isn't exactly working so far. Well, we may have to try the cutter up approach. Okay, here's the 10 snips. Oh, that was the break it off approach, not the cut it up approach. Here's bolt cutters. Look at all that impressive. Don't know if you can see that there's some impressive dust that came off of there. Don't try this at home, kids. My experience with these things has been either it's a one-way ticket and you have to destroy the thing to get it apart, which was true in the case of my Bose Cinemate video, if you'd like to go check that out. Or sometimes it turns out it was possible to get it apart, but you just had no way to figure that out without destroying it first. I'll keep at this, and we'll get back to you when the answer is apparent. Well, it looks like I've repeated a mistake I've made before, which is some of these screws are inside under here that I just missed. So a lot of times when you're having to apply a great deal of force to something and it isn't even budging at all, that means there's still screws to be taken out. So we've got it turned the right way again with those screws taken out. This whole top that I've been struggling with kind of pops off. It's got a sticky spot right here, which tells me there's another screw to be done there. So here we are from the top again with the control panel, the water inlet for the espresso, which it looks like is kind of a boiling tank in effect. That's why it has this fairly tightly sealed lid on it. Water comes out here when the pressure goes up. This is a flow switch, just purely mechanical. And also there's a switch mechanism here. This is a lever that holds the coffee holder in place, that holds the grounds, and it seems to have some sort of a, maybe that just plain lets in air or something, I'm not sure. We'll have to see when we look better. So here's the back of the control board and our 4 major wires here, which are really for the 2 heating elements, I assume. I flipped things over. This is where the water comes out through the espresso grounds cup. Finally figured out what I want to call it. These are little plastic clips. It looks like this is kind of a one-time clip it in type thing. So I'm going to apply some persuasion to that and pull that out. That's kind of keeping me from going anywhere. And here I see on the thing here that this is closed versus steamed versus this is if you want espresso. Looks like you select with that. So this water control switch, which I'm reoriented here, works into this plastic assembly. That's pretty important to the operation of espresso. So after a lot more destruction with the primarily with the bolt cutters, screwdrivers, other things, I've separated. This is entirely plastic of no reuse value at all. Got the little espresso handle, which I can also live without. And here is the good part, as well as a bunch of screws and some other miscellaneous metal and plastic pieces. Here I've got all the major electrical parts laid out. Taking this partly for documentation to see how all the wiring is, because I'm going to take this apart so that I can look at each element individually. Although I didn't plan to fix this, and of course that's not possible after all the destruction, but I may end up reverse engineering it, or at least finding out what parts are bad here. We can throw away whatever part is bad. I suspect it's either this heater element, which is the main heater element for coffee, or else it could be one of these temperature sensing switches here. Now another element that I've heard about and I'm just now seeing is there's supposed to be a one-way mechanical valve here, a kind of a ball valve thing that allows the pumping action of the water itself to work. So basically the water bubbles up past the valve due to the heat and pressure involved, and gas is created as it reaches boiling point, steam pressure basically, and then as that cools off or whatever, it can't go back down. More comes up to replace it, pushes more out, and eventually this ends up at the top of the pot. So this has something in the middle of it, which I think is that one-way valve, and none of the other tubing does. Now I've tried blowing on this in both directions, and it will take air in either direction. So that makes me wonder if maybe this valve is broken. So this is the overall power on-off switch. We've got the voltmeter set on diode setting, which beeps like so when we have continuity. So this is pushed in right now. Take it out. So the overall power switch works fine. So I checked continuity on this wire. It goes both ways. This, I believe, is a power fuse that's kind of not replaceable like most fuses are. Again, this coffee pot really isn't designed to be serviced. It's designed to be thrown away once it stops working, which is exactly what we've done. Now, next, let's try. This is the main heater element for the coffee and the coffee pot. This, I believe, is a thermal switch. With everything cold, this should be a short circuit here, making a beep. Maybe that's the problem. You have to look into that more. So now I'm looking at the resistance of the heater element. That's showing a resistance of about 16.4 ohms. We can calculate what the power of that should be later on, but it should have 115 line voltage going into it. So we're going to say that this heater element is good. Not quite sure on this switch yet. So this is the espresso tank and element with captive element and other plastic parts. This is the tank lid here that's screwed on. We'll look at the resistance of that in isolation. That's showing 18 ohms on my ohm meter over here. Now this also has a thermal switch right here, which again I believe should be normally shorted, showing about 0.1 ohms. So this is shorted cold, which is what we would expect. This would only open up when this gets overheated, or maybe when it reaches some sort of intended temperature. I'm going to test this other switch on the first element with an ohm meter this time. That's showing open circuit. So I looked at this up close with a magnifier. Hard to tell, it looks a little toasty. So this might be the bad element right there. We've also got the fact that this valve doesn't seem to be working. We have one or possibly two reasons why the coffee maker doesn't seem to work. Maybe my blow test for this valve was not adequate. Maybe it has to be steam or water or something. But my guess is, from what I've seen, that this switch is the problem. It's a safety switch, and maybe we'll take that off and get some more data on it later. But for now, it looks like this element is reusable. I'm not sure that I have a real need for that, so that'll probably go in the drawer or get thrown away. So this espresso part looks more useful to me as a salvage item, imagine you have some sort of water boiling application, and actually I have one in mind for the future that we may explore. But we've got this little pressure tank cover, valve to control whether anything's going in or out of it, and a safety mechanism that appears to be working. So this assembly is worth keeping for some future steam oriented project maybe. Now another element that we haven't looked at yet is this little controller board. Taken off all the plastic parts that are kind of, we had plastic push buttons here. These are momentary buttons. LCD panel on off switch on the back. Looks like this is the main relay that controls. Here's where all the power goes out to the heater elements. Controller chip may have some sort of very simple unregulated circuit. Here's a diode, capacitor, power resistor. So assuming that this takes relatively little power in itself, we may be able to do all that with some pretty simple power supply components. So there may be something to save here, maybe not. Well, I think I found our culprit here. This is a thermal switch off the back of the main heater element that we saw earlier. And right now I'm on the diode setting of the voltmeter. No sounds coming out. It shows open circuit. But if I poke right in the center of this, so that means this is open at cold temperature. I wondered if maybe I had the wrong idea and somehow it shorts at hot temperature. I looked up the online data for this and it really does work as I had figured, which is it's normally closed at cold and then it goes open at hot temperature. So as I had guessed, this is an over temperature safety switch to go with this heating element that's the main element of the coffee maker. And right there in essence is why the thing would not make coffee no matter what, is because this element could never get heated, which is required both for making the coffee and then keeping it warm. Now the espresso element that we saw separately may have worked. I'm not sure if we tried that when the thing was still intact. But as I checked this out before, I found out that this whole assembly works as intended. So here's the control board. This was mounted for minimal cost. It had one screw in the center and it has these plastic clips. So this is again intended as a one-time design. These plastic clips are cheaper than screws and less labor. You just pop it in and you're done. So here's the side that had been concealed before. We've got these little momentary switches. There's an IC that I can see underneath here. You typically have an LCD controller IC, or more likely that's kind of integrated in with an overall microcontroller that runs this. The logic functions of it are fairly simple. You know, clock, different settings for the coffee pot, reading the buttons, and in particular operating this relay. I also found some additional ICs on this side and diodes, probably that go with the switches, and this may be a power transistor, power regulator that works with the power supply section over here. So this concludes our video. Thanks for watching. Please like and subscribe, and we'll see you next time. Bye bye.